Okay, let's go ahead and get settled in. Okay, so today we're going to start on essentially learning how to program in Java. So like I said before, we expect you to have programmed in some programming language before, some context, Python, MATLAB, TypeScript, etc. And so the first couple of weeks of this course, funny enough, are going to be exactly the same as 401. So I'm giving the same lecture twice for at least 2 weeks. And all we're going to do is we're just going to come up to speed on basic Java programming to the extent that you can translate your current programming skills. We're not going to talk about object-oriented programming or really talk about object-oriented stuff because that's not the point of this class. So once we kind of get up to speed, we'll go off and into data structures, while 401 is going to go off into kind of object-oriented design and that kind of thing. We just need enough of an object to glue some fields together into a data structure, hence the name of our course, data structures, and then we'll go off and do more data structure-centric things. But to begin with, we just need to be able to write simple, basic programs in Java, right? So, So toward that end, just a basic overview of the Java workflow and how things are organized in Java. So in Java, all code is organized into classes and interfaces. We're just going to put interfaces aside. We're going to get to that in about a day or two. So we'll just talk about classes. But basically, code is organized into classes. And each class is in a file of the same name. Now, I'm going to say that as a blanket statement, but some of you who may know Java or have experience with Java will know that that's not technically true, right? So I'm sometimes going to say things in a blanket manner as if they were always true when they're only generally true. And if you know better, just kind of keep it to yourself, right? I mean, yeah, I don't have time to go in and explain every nuance and corner case and when it's not technically true, that kind of thing. I'll try to point it out when I know I'm telling you something that is, sometimes not true. But for the most part, I might sometimes make these general statements that are generally true, and then later on in the course, we'll back away from them when we kind of have a better sense of things. So for now, just assume that all code in Java is organized into classes. Each class is in its own file, and that file happens to have the same name as the class name, right? We'll talk about the structure of a class and exactly what a class is as we go on today, but that's the basic organization of code in Java, right? Now, the other thing that you might not be used to is this notion of a compiled language. Java, like C and C++, is a compiled language, which means that we write our code, in this case, into these files that represent classes, and then we compile that code using a compiler, a program that transforms, analyzes and otherwise transforms that code into bytecode. And so there's the translation from the source code, those files end in .java, to the compiled bytecode, which will have the same name, but they'll end in a different ending. They'll end in .class. And it's really those .class files that the Java runtime system is using to actually execute your program. So there's 2 steps. First, compile to bytecode, and then take the bytecode and run, right? And so the way to run a Java program is to indicate to the Java runtime engine, so that's a program that's called Java, as opposed to Java-C, which is the compiler. But the point is we tell Java, please start with this particular class. And what Java will do is it'll look into that class, and it's looking for a very special and specific function, right? So it's looking specifically for a function that has been defined with the following declaration: public static void main string array args, right? We'll deep dive into each part of that. But basically, any class that contains that method, that function, can be the starting point of a program. And so once I indicate, here's the class I want to start on, and the Java runtime finds the magic function, then that is where your program then starts. Okay, so So we have code organized into classes. Classes, furthermore, are organized into something known as packages. You can have as many classes as you want into a package, but every class belongs to exactly one package. It is possible to write Java code where you have a class that is in no package, like basically an unnamed package, but that is really poor form, and so you should always think of classes as always belonging to a single package, and a package basically being a collection of classes. All right. Okay, so like I said, a package is a collection of classes. The way we indicate what class a package a class is in is at the very beginning of a class's source code file, or, a Java file that represents a class, will be the statement, a package statement. So that's usually the very, very first thing in any file that represents a class, any source code, is this package statement indicating this class will be in this package. Package names are usually lowercase, and sometimes they are formed with words, essentially, separated by dots. It's all one giant package name. So even though the dots are kind of used to give a sense of hierarchical kind of structure to the package names, the whole thing is a single package name, right? Let's see here. What else? Okay, so then the actual syntax of what is after the package statement is the class definition itself, and should look something like this. So public, again, we'll explain that word in a bit. Class, the actual name of the class, open a curly brace, and then the body of the class, and we'll talk about what goes inside a class in a second, and then end curly brace, and that defines a class. So, So what we're going to do is we're going to consider a class for now just to be a container in which we're going to be able to define one or more functions or procedures, right? So a class actually is a little bit more than that, or actually a lot more than that. But for now, that'll do. That'll serve our purposes. That a class is simply a place where we can define a whole bunch of functions, and now we have a whole bunch of functions that are in that class, right? And so in Java parlance, we use the word method instead of function or procedure. But it's neither here nor there. It's just a word. It's just that that's what the Java community uses when they're talking about functions and procedures. And so that's the word we'll use, right? So if you're talking to other Java developers, method is the name of the word that's going to be, is going to make sense as a function or procedure. So I'll use function and procedure and method kind of interchangeably right now, but eventually I'll just stop saying function or procedure and I'll just say method, right? So a method is like any programming language. You want to be able to define a sequence of statements, a sequence of kind of actions, and wrap that, and call it something in a way that I can call that sequence and have that sequence of instructions execute, right? So every programming language has a way of defining functions and then be able to call those functions and procedures from other functions and procedures. And Java is no different. Right? So, So when we call let's see here. Let's just go on and look at an example. So here's an example, right? So let's just start with an example. That way we can kind of see what we're talking about. Here is an entire Java program written as one class. Okay? So this would all be in one file. The name of that file would be the same as the name of the class. So presumably the file's name is averageheightApp.java. That would be what the file name is called. Inside that file, we might see this code. There should be a package statement at the very beginning. I've left that out. That's OK. But here's the remaining, what else would be in that class file or in that Java file. So we have public class averageHeightApp, right? That declares that this is the name of the class. And here is the body of the class. The body of the class, in this particular case, is comprised of two methods. We have our magic main method, which is declared in a very specific way so that it can be the start of our program. And we have this other method called read height data. And we can see that, you know, when we start off in main, the very first thing we do is we're declaring a variable heights, which is a double array variable, basically can point to a double array, and we are setting it equal to the results of having invoked, having called this other method that's defined in our class, read height data, right? So that very first line inside main calls the other method. The other method defines an array of double values in a local variable and returns that local variable, so returns that array. And so then what's on the right-hand side of the equals will be the result of having called that method. And then I've taken that result and I've put it into this heights variable, which is local to main. It's a local variable, right? So then the next thing I do is I declare another local variable. And tomorrow, and on Thursday, we're going to really dig deep into what it means to be a local variable inside of a method. But for now, basically, it's a variable name I can use inside this method, right? So the next one, the next line, defines another local variable called sum of heights and initializes it to 0.0. And we can see whenever we're creating these names, it always, like when the first time we use a variable, the first time we need a variable, we have to declare it with its type. So we have to indicate what type everything is. And we'll see this come up over and over again in Java, that it's constantly asking for us to provide type information so that it can match things up, right? The type of something that's being returned, the type of a variable, etc. So here we've established sum of heights as a double, right? Just basically a real value, and it's set to this value 0.0. The next few lines should be recognizable to you as a for loop, right? And we'll go over the syntax of a for loop later. But basically, we're iterating or going through each index of the array, collecting the values from the array that we have in heights, right? That was the array that was produced by this other method, right, at the very beginning. And we're going through and collecting each of those numbers into the sum. And then we are calculating an average, right? Again, we declare the average height as a double, and we set it equal to some expression that is its initial value. And then the last line basically prints things out, right? And we'll actually do this, right? And so in order to actually do this, right, let's demonstrate doing this in Eclipse. Now, you don't have to use Eclipse in order to program in Java, right? Obviously, you could create your own .java files with all your code. You can use the command line in order to invoke the compiler, in order to turn those Java files into class files of compiled bytecode. And then you could use the Java runtime engine on the command line to run a particular class as the main program, right? But for the most part, we don't generally do this by hand. We do this within an integrated development environment. And in this class, we're going to use Eclipse. And so Eclipse basically, the next few minutes, I'm going to demonstrate writing this code in Eclipse, right? And so Eclipse kind of takes care of a lot of these things for us, keeping track of where the files are and their relationships to each other, whether they're compiled or not, and which one we're trying to run. Provides code completion tools and a debugger and a lot of features, and it's really quite powerful. We're not going to use a lot of the power of Eclipse. We're just going to kind of concentrate on the bread and butter stuff that we'll need for this class. But it's it's actually not an unreasonable IDE. It's not the best IDE, but it's not unreasonable either. All right, so when we start up Eclipse looks something like this, right? Where we see our workspace. Sometimes the very, very first time you start Eclipse, it'll show you some, this view with icons, and there'll be a button that says Go to Workspace, and you can make it so that it doesn't go to that initial view and just goes straight to your workspace every time. But the point is that we get to this workspace, and this is kind of an empty workspace. There's no projects, there's no code, everything is empty, right? So this left-hand panel here, the Package Explorer, that shows you all of your projects and allows you to then dive, to expand your projects, to see the code inside the project, and then to go to each file of inside that project and essentially select it for either running or editing or whatever, right? So basically, it's kind of the explorer for all the projects that you have in this particular workspace. You can see I don't have any, right? So I want to demonstrate how to create one. So I'm going to create a new project by saying File, New, Java Project. And I want to say Java project specifically because Eclipse supports lots of different kinds of projects, each one of which is kind of set up specifically for the development environment required for that particular language or that particular kind of project. And so we want to make sure that, that we get ours set up correctly for Java specifically. So when you select to create a new project, you definitely want to create a new Java project, not just a new project, a general project, or a new other kind of project, but a new Java project, because it will mean something to Eclipse. When you do that, you get a dialog box asking you for the name of the project, and I'm just going to say Lecture 2 test, right? And then it will ask you for whether you want to create a module name. Now, Java modules is a relatively new feature to Java development. It's very useful for large-scale projects where you're going to use code or reuse code across different projects, and you want to kind of keep track of revision history and and basically a lot of software engineering principles that are very useful for larger projects that are being worked on by lots of developers. For our stuff, we don't really need modules. And furthermore, the AutoGrader, for some reason, I haven't quite figured it out, doesn't really like it if you create a module. So I'll eventually figure out exactly what's wrong with the AutoGrader and why it doesn't like modules and fix it. But for now, I'm just going to prescribe to you, don't ever create a module, right? Just avoid the situation. Its benefits and features are not worth the hassle at this point, and since we're doing relatively straightforward things. So whenever it comes up with this dialog box that says, create module info.java and asking you for a module name, you just don't want to create a module name. So I always click this button, don't create. What's going to happen is, and I know it's kind of hard to see because the fonts on the editor are bigger, I promise, but the interface fonts aren't so great. So you're just going to have to trust me in terms of what you're seeing. But what we see now on this Package Explorer is we see a listing for our project. And if you go inside it, you'll see that it already has things in it. Java's already set things up. It's set it up with a source directory that's currently empty. And it has a whole bunch of system libraries that it is automatically imported and kind of made part of your project. So now that we have a project, the next thing we want to do is create a new class. And remember, every class belongs to a package. So before we create a class, we need to create a package. So I'm going to right-click on source and say new package. And then I have to give a package name. And so here I'll just say lecture 2 test, or .test maybe. Right, and now that created, you'll see now that we have an entry underneath our source directory for our package. And so then we can right-click on our package and create a new class. Right, and now we have to give it, we'll get a dialog box that allows us to configure our class in lots of different ways. Usually the defaults options are all just fine, and we just want to provide a name. Now remember, the name of our class is the name of our file and is the name of, and those things have to match. So in order to kind of match our example, remember our example said that our class name was average height app. So that's the class name I'll use here, capital A. And it creates that file, right? We can see average height app.java. And then, when you create a new class, it automatically puts it up into your editor. Can everyone see that font size, or should I try to make it even bigger? We're OK with it? All right, good. All right, so, and now it automatically kind of creates this empty class waiting for you to put your code into it. So here is a class. There's our package statement indicating what package it is in. And then there's our class declaration. And of course, it's empty. So now we need to fill it with our code. And I'm just going to, instead of retyping it, I'm just going to cut and paste it from here. Put that in here. And there's our code. And we can see that Eclipse does some nice things for us. It highlights keywords, and otherwise, if our indentation's all wrong, we can just kind of select everything and, oops, select everything and hit Control-I, and then it'll re-indent everything, so everything's nice and indented correctly. And this is where we can start to develop, right? We can add more methods or otherwise work on our code. When we want to run our code, we need to select a specific class to be our main class, to be where we're trying to start, where we're telling Java, look in this class for a static main method for where to start, right? So to do that, we go to our package explorer. We highlight the class name, right? Average app.java. It's the only class we have. We might have had more classes, but this happens to be the only one we have. So we highlight that, and then we hit this little green play button, and it will run. Now, I made some minor editing changes in order to demonstrate the indenting part. So I hadn't actually saved my file since the last change I made. And so Eclipse will detect this and say, hey, do you want to save that file before running it? Right? Do you want to save everything before running it? So I say, yes, OK. And now it runs. And we can see it came down here. Here's our answer down here, right? So this is our console window. Whenever we print to the standard output, whenever we use Java to print to the standard output, or we read things from the standard input, that keyboard input and that output comes from and goes to something called the console window. And the first time your program will put something out to the console, that console window usually pops up down here. Now, if you ever lose a window, for example, if I throw that console window away, or I accidentally throw this package explorer away, and now, what happened to my package explorer? What happened to my console? I want to get it back. Well, you can always find a window view, a sub-window within Eclipse by going to the Window menu and going to Show View. And then under Show View, there are all of the different possible little tabs that have things in it, right? And these aren't even all of them. These are just the most popular ones. And then if you really want to see all of them and you hit Other, then there's like every single possible tab of information that Eclipse could provide for you. So I lost my Package Explorer, so I can go to Show View and go to Package Explorer, click that, and then it'll pop back up, right? I lost my console, so I can go to Show View and then go to Console, find console, there it is, and it'll pop back up. So if you ever lose a tab or lose a window, you can get it back by navigating through the window menu to find what you're looking for, and it'll pop back up. It'll pop back up where you last put it. You can rearrange these things. It's all kind of sticky. So like if you start moving windows around or de-docking windows or docking them to different sides of the screen or that kind of thing, it'll remember your last choices. So if you're into that, if you're into like customizing everything, you can do that to your heart's desire, right? OK, so that, in a nutshell, is how you create a very simple Java program where you have all it is just some methods defined inside a single class. OK. So we demonstrated starting the Eclipse workspace and creating a new project, creating a new package, creating a new class. We put some methods in that class, and then we executed it, right? So with just that, right, you should be able to write fairly simple, straightforward programs where everything is just all in one class, and you've just separated it into methods as you need, with the starting point being your main method. Right? So now I'm going to go through a few of the smaller kind of atomic details for how things work in Java. Some things I'm going to skip over pretty quickly because they're pretty easy for you to kind of understand or learn on your own. Some things I'll stop and kind of give a little bit more explanation because I want to kind of give you a better sense for what's going on. So obviously, Java has comments. Figure out how to use comments. There's a way to comment, right? More importantly, there is a fundamental dichotomy in Java between what's known as the value types and what are known as the reference types, right? So built into Java are 8 basic value types, and we call them value types because those types are completely determined. Like what they represent is they represent a bit pattern in memory of a certain length that is completely defined by that value, whatever that bit pattern is, right? And so these value types are for things like integers and real numbers and booleans and characters, and there's only 8 of them, right? There's 8 value types. Then everything else in Java is an object or some kind of object, right? So the value types are just essentially just values defined by some sort of bit pattern, which is however long it is, but it's just that's what it is. It is that value. Whereas all the reference types are structures in memory that are a little bit more sophisticated and with respect to their type information and whether they have fields or methods associated with those objects, and so are a little bit more interesting, right? They're not just simple values, right? So everything else that's not one of the value types is essentially an object, is a structure in memory, right? And so that means strings are a structure in memory, so they're a reference type. Arrays are not just simple values, they are actually a sequence of values, so it's a little bit more structured in memory, and so arrays are a reference type. Any object is, typed by its class name is, and we'll talk about what that means in the next couple of days, is an object and therefore is a reference type. Even the classes themselves technically are objects in and of themselves that exist in memory as structures and are, and can be referred to through, their a reference to that structure in memory. And so that's the way to understand these things, is that value types are defined by a particular bit pattern, which is that value. The reference types, the value of a variable that is referring to a reference type, like a string variable or an array variable or a variable that's pointing to some kind of object, right? What's in that variable, the value of that variable, is not the actual memory that is making up that object. Instead, the value of that variable, of a reference type variable, is a memory address, is a reference. That's why we call it a reference type. It's a reference to some spot in memory where that structure exists. Okay? So value types defined by their value, reference type are defined by a reference to some spot in memory. All right. Okay, so what are those value types? Quite quickly, there are 4 kinds of integers: byte, short, int, long, and those are the type names. And again, type names are going to come up a lot in Java. So if you're coming from a Python or a background, it's going to be a little weird because that language doesn't really have a strong sense of type, whereas Java is strongly typed. So we are often going to have to indicate the type of a variable, and if the type is one of these 4 kinds of integers, then the type names for these 4 kinds of integers are the keywords, the literal words, byte, short, int, long. Those are the 4 type names available for integers. And the difference between them is how many bytes are used to store the value. A byte is 1 byte, a short is 2, an int is 4, a long is 8. And the difference between the different sizes of integers is the range of numbers that they can represent. So for a byte goes from -128 to +127. Short goes from -32,000 something or 16,000 something to +16,000 something, et cetera, right? Now the most common form of integer, and the one that is just kind of the one that we're always going to use because we don't really have a reason not to use it, is int. INT. So for the most part, we're not going to use byte as short or long. We're always going to use int. It's got plenty of range. It goes from -2 billion to +2 billion and should do us just fine. There are reasons to use these different sized integers in different places, often related to performance, but we're ignoring all of that right now. We're just going to kind of program to the most common case. The most common integer type is int, and so that's the one we're going to use. Okay? One thing that is different than some programming languages is that for these integer types, there's no unsigned version. So in some programming languages, there's a way to say, here's this integer value, and it's not signed. It's going to always be positive. It goes from 0 and up, right? In which case, you don't have to, like, you can use the whole bit pattern for the number from 0 all the way up to however many bits that you have in the number. In Java, we always have negative numbers. We can't not have negative numbers. So we lose, even if you want a integer for just a unsigned value, and you know that value is never going to be negative, there's no way to create a special integer type that won't allow negative values or is able to use more range because it doesn't need to have negative values. All integers in Java are signed. And then we can, of course, specify numbers literally using either decimal notation or hexadecimal notation or even binary notation. But that's essentially the 4 types for integers, and we're only really going to use int. Right? There are 2 types for real numbers, basically numbers with a fractional component. And there's a strong difference between integers and real numbers in Java. Some languages don't make a distinction. Java does. Integer math and real number math are not necessarily the same. And we have to be careful when we mix and match them. We'll see that in a bit. But there's 2 types of real numbers, float and double. We're only going to use double. The differences in the precision, we don't really care about the details of why they're different or how they're different. We'll always use double when we want real numbers. There is a character type. So char is a character type. It happens to be a 16-bit value, but it doesn't really matter to you. But basically, a single character can be represented by a character value of type char. So the character C, there is a specific value, char value, that is that number, that character C. The mapping between the bit patterns, the 16-bit bit patterns, and the specific character they represent, that mapping is a standard mapping called Unicode. This is an international standard for mapping 16-bit bit patterns to characters, right? That's just a specific way of doing it. It is widely used. It's a widely used standard, and so that's what Java uses. It uses the Unicode standard for characters. Now, in some programming languages, there's no difference between a single character and a string of characters that happens to only have a single character in it, right? That's not true of Java. Those are 2 different things. We have a value type for individual characters, and then we have a reference type, a structure in memory, for a sequence of those characters that represents a string of characters or a string. So there is a difference between the char type and the string type, and a single character is not the same thing as a string that happens to only be 1 character long. Okay? And then finally, the last value type we have is Boolean. And Boolean basically has only 2 possible values, true and false. Right? That's the whole point. So there is a specific and special value type for the idea of true and false. And whenever we need to evaluate things in a Boolean context, well, we will create or need an expression that produces this type of data. It needs to produce either true or false. In some other programming languages, there is no true Boolean type. They just interpret all the other types with respect to the idea of being true and the idea of being false. So, for example, in C, if you happen to have an integer, a 0 is interpreted as false, and anything that's not 0 is interpreted as true. That is not the case in Java. In Java, there's no interpreting of the other types in a Boolean context. No. Instead, we have a specific Boolean type which explicitly represents true and false, and we have operators and ways of dealing with Boolean values in order to evaluate if something is true or something is false. All right. Okay, so going back to the idea of defining methods, right? So right now, all we have in Java is we have a bunch of classes. The classes are organized in packages. Each of the classes has 1 or more methods defined. One of those methods could be the main method where we can indicate, please start here and start executing, right? So let's go into exactly how that method is defined and what that method looks like. This is a template, kind of a blueprint for a method declaration or a method definition, and that we're going to go through in pieces. Right? So the first piece is the static keyword. I've put it in brackets in order to indicate sometimes this is here, sometimes it's not here. So the brackets aren't part of how we define a method. So those square brackets are just there to indicate that static keyword is optional, right? So the static keyword is, if it's present, it basically says, or what it means is that the method I am defining here is a class method. It belongs to this class as a whole. That is in contrast to a method that is known as an instance method, where, and the difference here is that if I have a class method, also known as a static method, I can use that class method without having to have an object that represents a particular instance of that class. And again, now I'm starting to use words that maybe you don't know or it doesn't really make sense. Don't worry about it, right? You will eventually know exactly what that sentence means. But the idea here is you can think of this as anything that is marked as static exists when everything starts, right? I don't have to create anything new in order to get to it. I don't have to have an object reference in order to call this method. Instead, I can just call this method however I want, simply by accessing it through the class name. Okay? So static so right now, for now, all of our methods are going to be static, and we'll eventually get to the point where we start using instance methods. But for now, all our methods are static. They all belong to the class as a whole, and we can access them through the class name. The next thing is going to be something known as an access modifier. An access modifier is going to be one of 3 possible keywords, or it could be absent. This is actually the part of Java that I hate the most, there's lots of things like this, where there are 3 special words that all mean something specific, and then the lack of the word also means something specific and is possible, right? I would have preferred that if they wanted 4 different kinds of access, they would have 4 different kinds of words, and one of them will always be there. But instead, they have it set up like this, where there are 3 special words for those kinds of access, and then the lack of a word or not having a word indicates this 4th other kind of access. So the 3 words that could be here are public, protected, and private. And then, of course, that word might not be there at all. If those 3 words aren't there, then the method is known as package private, or basically not public, not protected, or not private, right? So public kind of says what it means. That means that this method can be used anywhere. It is public, right? It can be used in this class. It can be used in a different class of the same package. It can be used in a different class in a different package. Basically, it is completely available anywhere, right? Protected, I'm not even going to get into. We'll learn about what that means later. Maybe we won't even learn about it at all in this class because that's not the point of this class. We're kind of concentrating on data structures, right? So just ignore that for now. Private is basically the opposite of public. If public basically means it can be used anywhere, private means it can only be used here, right? So private basically says this method can only be used within this class. So it can be used by other methods in this class. So any other code in this class is free to call this method, but we can't access this method from outside of the class, whether it be in the same package or not. Right? And then finally, the no modifier case happens to mean it's like halfway between public and private. It basically says that it can be used in this class for sure, but can also be used inside a class of the same package. So no modifier means that it's available to every class in the same package. Now, static and the access modifier, or static or not, not having static and the access modifier, those 2 things can come in any order. There's no specific order to those, but those 2 things have to come first. in some order. And then the next thing that comes is the return type for the method. Again, remember, Java is strongly typed, and so we're often expressing what type something is. In this case, what we're expressing is the type of the value that is produced by this method. When we call a function, we get back a value, right? It produces a result. We need to, when we define a method in Java, we need to indicate what is the type of the result that this method will produce. And it can be one of the value types, right? Int, long, byte, short, character, right? Boolean. Those are perfectly valid kinds of values to produce. It can also be a reference type. It could be that this method produces a reference to a string, or a reference to some other kind of object, or a reference to an array, or a reference to any other of the reference types. So the return type is simply the type name, the type associated with the value produced by this by this method. All right. Now, some methods are really procedures. They're not functions. They're basically a sequence of statements that have some side effects or maybe get some work done, but don't actually produce a value at the end of the day, right? And so a procedure, a method that's acting as a procedure and doesn't have a return value, will not produce a value. They have a special keyword to use in that situation for the return type, and that's void. So if we indicate void, that doesn't mean that we're going to create a void type. Void is not a valid type, right? It's basically an indicator that there is no type, right? So that this method is not going to produce any sort of value. Okay. All right, for now, let's go ahead and do a little interactive kind of wake you up kind of thing here. So now that we know a little bit about types and reference types, right? There's we can answer some questions about these types, these examples here, right? So what we're going to do is we're going to have we're asking the question, which of these types are reference types and which ones are value types? I'm going to give you a minute to think about it. Feel free to confer with your neighbor, and then we'll come back and we'll discuss. Go for it. All right, let's bring you back in. I will play a little game here, right? So we'll go through a few of these, and for each one, I'll basically, ask you guys to decide whether it's a value type or a reference type, and then we'll give a little count to 3, and then we're going to say a little go heels, right? So we'll say 1, 2, 3, and everyone who thinks it's a value type will say go, and then everyone who thinks it's a reference type will just shut up for a second, and then when I raise my other hand, everyone who thinks it's a reference type will say heels, right? So go is value, heels is reference, right? So int, right? On 3, 1, 2, 3. Go. Good, no one got it wrong, right? Exactly, int is a value type, right? Now let's try string, right? 1, 2, 3. Heels. There you go, right? No goes, all heels, right? Now let's get it a little trickier. Boolean, open square bracket, close square bracket, right? Think about it for a second. Okay, on 3, 1, 2, 3. There you go. It's Boolean itself, of course, is a value type, right? We talked about that, but this isn't just a Boolean. This is an array of Booleans, right? And so that's what those square brackets after a type mean, is array of. So every time you see square brackets as part of a type declaration in Java, it's essentially saying array of, right? So Boolean square bracket and square bracket as a type designator is array of Booleans, which explains this bottom one, string square bracket, square bracket, square bracket, square bracket, right? That is an array of an array of strings. So it's like a two-dimensional array, if you will, right? We'll get into arrays later, not today, but soon. Yeah, so good job. Okay. Now we have to have a name for our method, and a name there are certain rules about what names can be in Java. I'm not going to go over all the rules in particular, but in general, don't ever start names, any kind of name in Java, with a number. And in general, we're going to reserve names that start with capital letters for class and interface names. Okay? I cannot stress this enough. Do not name your methods starting with a capital letter. Do not name your variables starting with a capital letter. Do not name your fields, and we'll explain fields when we get there, with names that start with a capital letter. The only names that should start with capital letters are classes and interfaces. All other names, they can have capital letters in them, but they should not start with a capital letter. Now, it's not illegal to start a method name with a capital letter. It's not illegal to start a variable name with a capital letter. But the convention that names that start with capital letters are reserved for class and interface names is so strong in Java that another Java programmer reading your code will get very annoyed if you have a whole bunch of names, variable names, method names, whatever, that start with capital letter that are not classes, because it will be confusing. So whenever we see a name in Java that starts with a capital letter, it instantly should think to yourself, oh, that's a class name, or that's an interface name, because those are the only names that should start with capital letters. It is unfortunate that the convention for doing this is so strong that you almost never use letters, any names that start with capital letters for anything other than class names, but it's not necessarily illegal. So, you could come across somebody writing code that is using capitalized names for things other than classes and interfaces, but it'll be very annoying. In this class and for your code, until you have some brilliant reason to do otherwise, don't do it. All names for methods and variable names should not start with capital letters. Only classes and interfaces should have names that start with capital letters. All right. And then the last thing inside a method declaration, or the last thing that's part of it's it's the declaration line, is inside parentheses a list of parameter names and their types that this method expects. Okay? So this is a comma-separated list, and each parameter will start off. Each parameter in the list is got its type and then the parameter name. And so the parameter name acts as a local variable inside the method. So if I define a parameter that takes in if I define a method that takes in two parameters, the first one is an integer called A, and the second one is a string called B, then inside, once I call that method and provide values for calling that method, then inside, that method starts executing, and inside that method, A will be the value I provided it, and B will be the value I provided it. But the list of parameters in my declaration indicate what not only are the names of the parameters, but what their type is and in what order they're expected to be provided. Unlike some other languages, Java does not have a notion of named parameters or parameters that can come in different orders. You have to provide the parameter values in the order that they're declared for the method that you are trying to invoke. So, for example, examples of what these parameter lists might look like include, there we go. Oh, no, that's not good. Right. So examples of what these parameter lists look like are down here. Here is a parameter list that is 3 parameters, right? The first one is an integer A, then an integer B, then an integer C. So type specifier space parameter name separated by commas inside parentheses as part of the declaration. Then the body of the method is inside the block of statements that between the open curly brace and the end curly brace, and this is just a sequence of statements that makes up this method, right? That is what this method is and does, right? And that's the code, right? That's where we're going to code our methods, our functions to do things. All right. Okay. Having said that, if we now look at some examples of method declarations, I didn't bother with the body, we're just looking at the declaration line, we can now hopefully come to understand how some of these work, right? So the first one is the magic method declaration that's necessary for the main method inside a class if we want it to be the starting place for our program, right? And so public static void main string array args, right? Now we know what that means. Public, it's accessible everywhere, not only in this class, but in any class, in any package. Static, it is a class method. That means that we don't have to have an object in order to invoke it. We can invoke it through the class name if we wanted to. Void, it won't return a value at all, right? There's no value produced. Main, that's the name of this method. String array args, it takes one parameter. It is an array of strings. Right? So that's how that, now we know enough to be able to interpret that declaration line. Here's a different one, int foo, right? So no public keyword, right? No private keyword, no protected keyword. That means that, it must be package private. Basically, this method is available in this class and in any class in the same package. No static keyword. That means that this is not a class method. This is an instance method. That means that this method, unlike the ones we were going to use for now, does require an object in order to invoke it, right? And again, we'll get into more what it means to be an instance method more deeply later. For now, we're just going to ignore instance methods and just work with static methods. But the fact that there isn't a static keyword in its declaration allows you to read this code and know that, this method is not a class method, right? Int, it returns an integer, right? So it is going to produce a value if you call it. The name of the method is foo. It takes 3 parameters. The first one is going to be an integer. The second one is going to be a reference to a myType object, right? And now we see that, myType starts with a capital letter, must be the name of a class. Class names are also type names, and we'll see why later. But the point is that when we see a capital letter for a type, right? That means that, this is really an object. It's an object that has been created by this particular type, and therefore, or this particular class, and therefore it is that particular type of object. So this would be a reference. B is expected to be a reference to some sort of object that is associated with the class myType, that was made by the class myType. And so that's it's a reference to a myType object. And then the third parameter is C, which is some double value. Again, we don't know what myType is or whatever. I mean, we don't need to at this point, but we know enough to kind of understand this method declaration and what the purpose and function of each of the words in that declaration is. All right. Okay. So going back to average height app, now we can kind of understand a few things, right? Here we have 2 methods defined in our class, our main method and our readHeightData method. Now we understand here this is a static method. That means that it's available just in through the class name without having to have an object. That's why we can call it up here without just by itself, plain, without having to use an object, and we'll talk about how you use an object to get to an instance method later. But the point is that as a static method, we didn't need that, and therefore we could just use it, right? We can use it inside this class because it's defined inside the same class, right? You can always use methods defined inside the same class. It happens to be, package private. There's no access modifier. So if we wanted to use readHeightData as a method in some other class in this same package, we could have. Right? But we couldn't use it in a class outside of the package because in order to do that, we would have had to have marked it as public. If we had marked it as private, then we would only have been able to use it inside this class. All right. Right. And so I think that's pretty much all I needed to point out there. All right. So that's actually a good point to stop and see to make sure that there aren't any questions that have come up, concerns, something you saw that you didn't understand, want to know more about. We're doing decently? Yes?
So when you do the public static void main in the where's like the string array that you put in?
So what string array do you put in for args, right? All right, so it turns out for this main method, we never call main, right? The system calls main because we told it, oh, start here, right? And what it did is if we happen to start this program on the command line, right, then it would have taken any arguments that we had written on the command line after we told Java, please start at this class, and invoke this program. It would have taken all of those strings on the command line, turned it into a string array, and started with this method main, and it would have provided all of those command line arguments in this args parameter, right? So since main is always the start of our program, we're never ever calling main ourselves. And so it's not us that has to put together that array of strings. When the system calls that main method to start the program, if it was done on the command line, it will take the command line arguments and create that array from those command line arguments so that your program can have access to them.
In relation to main, like above or under, does it matter where you
No.
define or construct?
The order of these methods within a class does not matter at all, right? Now, typically, if a class has a main method, it's usually one of the first things, right? Or one of the last things. There's a couple different conventions, right? But order within the class of anything doesn't matter. Now, you should want to organize things logically, right? You don't want to just throw things in willy-nilly, right? So there are some conventional ways in which we organize things. We put all our static methods together. We put all our instance methods together. We haven't talked about fields, but we put all our static fields together. We put all our instance fields together. Now, we could have just mixed them all up and put them wherever they are, but then it would just make it that much harder to read and understand what's going on in the code. But order of these things inside the class does not matter. Good question. Go ahead.
So about the volume types, is there like a big header of volume types and it's primitive and reference, or is primitive the same thing as volume?
Primitive is the same thing as value. Like if somebody asked you in an interview, what are the primitive types provided by Java, right? You should say, the 4 integers, the 2 reals, and character and Boolean, right? Yeah. All right. Okay. So now that we've kind of have the structure of things, let's talk about the kinds of things that are actually in a method, like the things that we can use in order to program within a method, right? It turns out that almost every programming language really only needs just a few basic things before they can build with those few basic things pretty much any other feature that any programming language provides, right? Most things that are provided as structure as statement types within a programming language are either one of these few basic ones or syntactic sugar for more complicated ways of using those these few basic ones, right? So the basic types of statements that are in a method that you can program with are declarations of local variables, like if you need a new name, if you need to declare a variable, a local variable that you want to be able to provide a value. In Java, we have to declare those variables, right? So that's one thing that could happen. You could assign a value to a previously declared variable, right? You can do conditional execution. Conditional execution basically means if something is true, do one thing. If it's not true, do a different thing. It's an if statement. Every programming language has some way of being able to branch between two options. True, do this. False, do that, right? That's a fundamental thing. Almost everything else can be built on top of that, right? So an if statement, we need to have some sort of conditional execution. We need to have, and technically, you need to have some sort of looping construct, right? You need to be able to go over code over and over and over again until some condition is either true or false. So every programming language provides at least one, if not several different kinds of looping constructs, and Java is no different. We're going to have our bread and butter for Java is going to be for loops and while loops. we can call other methods, right? So we can either call other methods as part of some expression that we're building a value, and we'll see that in a second, or we can just call some other method because we know that method is going to go and then do other things that we want to do, like a procedure, right? But that is something that we can do inside a method, is to call a different method and either get back its result or call that other method for the work that other method is going to do, right? And then finally, if we're inside a method that has been called by some other method, then we may or need to return a value, which is our result, or just return, even if we don't have a result, just because we're done, right? So some sort of return statement, some sort of indication that this method has calculated the value it's trying to calculate and is now ready to return its result, or has done whatever is going to do. Maybe it's a void method, it doesn't have a result, but it's done whatever it wants to do, and now it just wants to be done and return from whoever called it, right? That's it. That's really the only kinds of statements you can have in a programming language, right? Almost everything else in any programming language is some version of one of these, or some kind of a construct that we could build out of this basic set of operations. Right? One thing to note is that anywhere in Java a single statement is expected, we could put instead a series of statements inside bracketed inside curly braces, and vice versa. Anywhere Java is expecting a block of statements, you can provide instead just a single statement as if it was its own block, right? So a block of statements and a single statement, interchangeable in Java, right? Okay, so let's start with the different kinds of things that we can see in a method, right? We could declare local variables. So the syntax here is relatively straightforward. The statement, all Java statements end in semicolon. Okay, so we basically have for a local variable declaration statement, we need to provide the type of the variable name followed by the name itself. So this first version says, I am creating a local variable name called name of type. If I want to create 3 variable names that all have the same type, I can do so by using the same type, a single type designator, and then following it by a comma-separated list of 3 names. Right? But the most common way of declaring a local variable is this third form. And in general, you should almost always use this third form, which is to declare its type, declare the name, right? So now you've defined a local variable of a particular name with a particular type, and then immediately give it an initial value. In fact, this idea of initializing your variables to some initial value when you create them is so strong that Eclipse, the Eclipse compiler, will actually, even though the first 2 versions are perfectly valid, will actually indicate either a warning or an error, I can't remember how severe, if you don't give your variables an initial value, if you don't use that third form. Right? So in reality, even though those first 2 forms exist, in reality you should always use that third form. Give it the type, tell it what the name is, use the equal sign to then provide an initial value. Now, once you've done this, that variable is now in scope, is available in the enclosing block of statements. So if you're inside a method body, then you're available everywhere inside that method body. Now, if you're inside a smaller enclosing block of statements, it's the smallest enclosing block of statements that you are defined for. So this allows us to define or to declare local variables inside the body of a loop, or inside one of the clauses of an if statement. And then, if we do that, then that variable is limited in its scope to just that block of statements. And in general, you should try to limit the scope of your variable to just where you need it. Right, so that it doesn't accidentally cause a bug if you use it in some other place accidentally without really realizing it. Right, so you want to limit your local variables to just where they're expected and needed. Right, and so the scope of a variable is determined by the enclosing block of statements. Parameter names are just like local variables that are in scope for the whole method body. Now, there are rules about variable names. I'm not going to go over them. You can read about them. The only one that matters is don't start variable names with a capital letter, ever. All right. Well, once I have a variable name and I've assigned it an initial value, then later on in the method, I might need to reassign a new value or update the value in some way. And so we can make it an assignment. Assignment, it just looks just the same as the variable declaration does. It just doesn't have the type part, right? So the first time I use a variable, when I declare it, I have to have the type of the variable, then the variable name equals, and then its initial value. Later, after I've already declared it, if I need to update or change the value of a variable, I can just say variable name equals, and then some sort of expression, right? So that expression on the right-hand side has to produce a value that matches the type of the variable. That's the whole point of Java, is that it's going to do a lot of static type checking just to make sure that things line up, that you're not, taking in something that's supposed to be an apple and assigning it to an orange, right? And so that expression on the right-hand side of this assignment statement has to produce a value has the type of that value needs to be compatible, needs to be to match the type of the variable that I am assigning that value. All right. So what's an expression, right? So an expression is basically a sequence of symbols that can be evaluated to produce a value. I'm going to say this again. An expression is a sequence of symbols that can be evaluated to produce a value. All right, what's her name? Alexis. All right, Alexis, if I've said this twice and I'm talking to you now, you read that first bullet, what do you think the first question on the midterm is going to be?
The first bullet.
Yes. The question on the midterm was going to be, what is an expression? And you are all going to write, say it together now, a sequence of symbols that can be evaluated to produce a value. Know it, love it, live it. I have had people get this question wrong, right? Have sat here and listened to me talk about how an expression is a sequence of symbols that can be evaluated to produce a value, and told them it's going to be the first question on the midterm, and then get it wrong, right? If you get that question wrong, you fail. It's going to be half the midterm, right? Okay? So an expression is a sequence of symbols. It can be evaluated to produce a value, and it can be used. You can provide an expression wherever a value is needed, right? So if you have some code and you need to provide a value for a parameter, a value for a variable, you can either provide the actual value itself, literally typed, or it could possibly be a compound or bigger expression, as long as it's an expression that can be evaluated to produce a value. Now, the type of that value has to match, sure, but that's what an expression is, right? So what kinds of expressions do we have? We have literal expressions, right? The sequence of symbols 1, 2, 3. That is literally the value 123 as an integer, right? The sequence of characters, single quote, C, and single quote. Those three characters, that's an expression. It is a sequence of characters that produces a value. What value does it produce? It produces the value of the character C, right? Even double quote, A space string, and double quote. That is a sequence of characters that produces a value. That value happens to be a reference, because remember, strings are reference types. That is the literal value, the literal expression of that sequence of characters is literally a reference to a string in memory that represents that sequence of characters. So obviously literal values are expressions, right? Because they just are that value. Obviously, if we use a variable name as part of an expression, or where we expect an expression, the value of a variable name will be the value of what we assign to it. So if we're expecting an expression and the expression is a_variable, then presumably that is the name of some variable that's in scope, and the value of that expression is the value of that variable. An expression could be the value returned from a method call. So if we have some place where we're expecting a value and the expression we provide, it looks like foo, open parentheses, close parentheses, right? It looks like we've calling a method. That's fine, right? Calling a method is a sequence of characters, right? So FOO, open parentheses, close parentheses. That sequence of characters is calling that method and then returning that value, and therefore that is an expression that evaluates to whatever value foo returned, right? We have things called fields. Again, I've alluded to it a couple of times. There are things called class fields. We won't, we don't really need to know the details, other than to know that classes can define essentially named constants. So math.py, math starts with a capital M, right? We recognize, that must be a class name. .py, basically that's how we're getting into the class field in the math class. Math.py is an expression that will return the value of that field inside the math class, right? And funny enough, math.py returns 5. No, of course. It returns 3.14, blah, 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 blah. I'm sure someone in here knows it to some nth degree. Don't start reciting it. And then, of course, we can always combine expressions with operators in order to create compound expressions, right? So operators are built-in little, basically mathematical operators or Boolean operators or whatever. I mean, they're basically things that can be applied to operands. So here is an expression, 4 plus 3 times 2. That is a compound expression. It is made up of sub-expressions, in this case, 4, 3, and 2. Each of those is a literal expression, right, a literal value, and they're combined with the operators plus and multiply, so that the whole thing is a compound expression that can be evaluated to produce a value, in this case 10. Right? Okay, so speaking of operators, we have lots of different kinds of operators in Java, right? This is not this should not all be should be not surprising. We have the typical arithmetic operators, the result of which is a numeric value of having operated on 2 numeric operands. We also have things like relational operators. Relational operators basically take 2 things that can be related or compared, typically numbers, and the result of a relational operator is going to be either true or false, right? Is A double equal B? I take A, I compare it to B. That whole thing, A double equal B, that's an expression, right? It's an operator, double equals, being applied to 2 sub-expressions, its left side and its right side, and together they produce a value. The value for a relational operator happens to be a Boolean value. It will produce either true or false, as does not equal, greater than equal, less than, or less than or equal to. We can combine Boolean values into, as part of expressions in order to create new Boolean values. So I can, the double ampersand is my AND logical Boolean operator. It expects the left-hand side to be a Boolean value, either true or false, and the right-hand side to be a Boolean value, either true or false. And then it basically says if my left-hand side is true, then the whole thing's true. If my left side is true, then look at my right side. If my right side is true, and they're both true, then the whole thing is true. And if either side is false, then the whole thing is false. Or is the 2 pipe symbols, basically opposite of and. It's whether the left or right side are either true, right? So either the left side's true, or or the right side's true. One of them is true, then this whole thing is true. If neither of them are true, then the whole thing is false. And then bang is the operator that you can put in front of a Boolean expression that just inverts it. So exclamation point and then some expression that is either true or false flips the expression. So if it was true, then it's false. If it's false, then it's true. All right, so we're actually running out of time, so I'm going to stop there. We're not going to go into a lot of detail on every specific operator. You can go and play with them yourselves. We'll pick up there on Thursday. Pay attention to Sakai, because I might point out slides on this lecture that I'm basically going to skip and then start further on next lecture, so we don't start falling behind. So if I am planning on skipping something, I'll usually send out an announcement saying, hey, these slides, study on your own, come with questions, and we'll skip them once we start on Thursday. All right.